Hello everybody, this is Dr. Nageswara, Assistant Professor of Physics, SRR and CVR Government Degree College, Autonomous, Vijayawada. Today we will discuss about principle of regenerative cooling. So this is very much useful for the liquefaction of all gases. We know already we discussed in the previous classes that for the production of low temperatures, there are three methods we discussed. One is freezing mixes, second one is Joule-Kelvin effect, and third one is adiabatic demagnetization. In Joule-Kelvin effect, when the gas is passing through porous plug from high pressure region into the low pressure region, it shows change in temperature. When whose initial temperature is less than inversion temperature, it suffers cooling effect. If whose initial temperature is more than inversion temperature, it shows heating effect. For example, at room temperature, hydrogen, helium, and neon shows heating effect. Remaining all gases shows cooling effect. But this principle is not enough for the liquefaction of gases because any gas to be liquefied whose temperature must be less than its critical temperature. So our aim is to obtain the below critical temperature to liquefy any gases. So the Joule-Kelvin effect is not only helpful, but also we will use principle of regenerative cooling to attain the critical temperature of that gases. So in this case, this is the experimental setup to get the low temperature, that is for the liquefaction of gases by using the regenerative cooling. What is regenerative cooling? Already we have in the name regenerative. It is nothing but again and again, which is passing through the piston and cylinder setup, where we apply high pressure up to 150 atmosphere, and it is passing to the water, then whose temperature reduced to initial temperature, and it is passing through the heat exchanger after Joule-Thomson effect, whose temperature decreases. If this temperature decreases gas, when they again entered into this porous plug material or porous plug experiment, it further decreases its temperature. We know that if the initial temperature of the gas decreases, the cooling effect is more. That principle is using here in this regenerative cooling to obtain very much low temperatures. So here, the initial temperature of the gas is very small, then the cooling effect is more, we know. So in this case, the gas or maybe air to be liquefied is entered into this piston and cylindrical arrangement, where we will apply 150 atmospheric pressure slightly, whose temperature increases. That is nothing but whose initial temperature is initial pressure is more, which is passing through the water. Because the water is at very cold temperature, that is low temperature, so whose temperature decreases and it is entered into the heat exchanger. The outer pressure is only 1 atmosphere due to this more pressure difference, that is 149 atmosphere. It shows more cooling effect if it is coming from the nozzle. So whose temperature is very much reduced, even though whose final temperature is not less than critical temperature, it is again back, and through this tube it is entered into this piston arrangement. So whose initial temperature is very less, so that further it is again passing through the porous plug through the nozzle, and whose temperature further decreases. So this method is again and again passing through this nozzle system, so that even when at such cases, when at some of the time whose final temperature is less than critical temperature, it can be liquefied. So this method is repeated again and again. Finally, the temperature of the gas reaches its critical temperature and hence liquefied. This is called principle of regenerative cooling. Thank you very much.